Okay, so today we're going to be looking at the product rule. Right, so sometimes you want to be able to find the derivative of a function that involves two simpler functions. Right, so for example, if I'm looking at f of x equals 3x minus 5 times 2x plus 7, I don't want to have to expand that every time. Right, so it would be nice if we could just find the derivative of each of those simpler functions and then multiply them together. Right, that would hopefully make sense and work. Well, let's see if that does work. Well, let's see what happens if I find the derivative by expanding it. So first off, f of x equals 6x squared plus 11x minus 35. Yep. Right, so that's my function if I expand it. So if I were to find that derivative using my power rule, I know that my derivative would be 12x plus 11. Awesome. Well, let's see what would happen if I just decided to take the derivative of the two binomials that we have there. Right, so if I have my f of x is my 3x minus 5 and 2x plus 7. Well, let's take the derivative of each of those, see if this works. Well, derivative of 3x minus 5 is just 3. Derivative of 2x plus 7 is just 2. And I'm getting the derivative is equal to 6. Well, clearly, they are not equal to us. Right? So, clearly that does not work. Unfortunately. Well, so we know we can expand and then find the derivative, but that's not always possible. Right? So for example, if I'm looking at some function that is, say, 2x minus 5 being multiplied by the square root of 3x plus 4, right? I can't multiply those together to find the derivative and expand it, take it term by term. So what do we have to do? Excuse me. Alrighty, so let's take a look and find what's called the product rule from first principles. So I have some function, let's say p of x. I have a function p of x, which is the product of f of x and g of x. Right, so I've got my p of x, which is the product of two other functions. Well, if I'm finding this from first principles, I know my p prime of x will be limit as h approaches 0 of f of x plus h g of x plus h minus f of x times g of x. Right, that's following my first principles. Okay, well, I'm going to force in a couple terms there. I'm going to have limit as h approaches 0. Ideally, I want to force something in so I can get to a point where I can common factor between a couple things. So I'm going to have my first term is still there. I'm going to subtract f of x plus h times g of x. Right? So if I subtract it, I then also have to add it. So then I haven't actually changed anything there. And then I've still got my minus f of x, g of x. I ran out of room. Okay, excellent. All over h. Well, now I'm going to common factor out of the first and the second. I'm going to split this limit in two. Maybe I'll do that in a couple steps here. So first I'm going to split this limit into two limits, taking the first two terms minus f of x plus h times g of x plus my properties of limits is what allows me to do this. Awesome. So now in each of those limits, you can notice there's a common factor. So let's factor that out. So we factored out a f of x plus h in the first, and we're factoring out a g of x in the second. Awesome. Okay, well, since I factored that out, I can also write this as the multiplication of two limits for each of those. So that gives me limit as h approaches 0 of f of x plus h being multiplied by limit as h approaches 0 of g of x plus h minus g of x over h plus limit as h approaches 0 of g of x multiplied by limit as h approaches 0 f of x plus h minus f of x all over h. Okay, well, take a look at the second limit of this. If I have the limit as h approaches 0 of g of x plus h minus g of x all over h, well, I believe that is the definition of g prime of x, right? My derivative of g of x. Similarly, this is my definition of the derivative of f of x. Okay, so what does that mean? Well, that means I have, if I take that limit as h approaches 0, right, let me just remind you of what that last line was. I had lastly there, my last line there was this. Times limit. Right, so that's what we had as our last line. Well, if I take that limit as h approaches 0, limit of h approaches 0 of f of x plus h, well, that just gives me f of x. We know that this is the derivative of g plus, well, g of x, and we know that's the derivative of f. So there you have it. There's my product rule. So if I have a function that is the product of two functions, then my derivative is equal to first times the derivative of the second plus the second times the derivative of the first. Right? That gets a little wordy to say. So a nice cool way to remember that just rolls off the tongue and is something that I was taught in high school that I still say to this day is second d first plus first d second. Right? So the second times the derivative of the first plus the first times the derivative of the second. Right? So if you just say second d first plus first d second, promise you'll remember that in 10, 20 years of how to take the derivative using the product rule. Awesome. So now we have a way of finding the derivative when we have two functions being multiplied together, so we don't have to worry about expanding those brackets anymore, which is always nice. So let's take some examples. Right, so we have f of x equaling x squared times x minus 3 squared. Excellent. Alrighty, so if we want to think about this, my first is my x squared, my second is that x minus 3 squared. Right, there's my first, there's my second. But we also want to think about that x minus 3 squared is x minus 3 times x minus 3. Right, so it on its own has a product going on there. Right. So when I'm taking the derivative of the second, I will have to be using the product rule to do so. That's going to bug me. There we go. Alrighty, so my derivative of f of x, so f prime of x, right? Second d first plus first d second. Okay, second is x minus 3 squared. Derivative of the first, well, that just uses our power rule, so I get 2x. Okay, second d first plus first, so x squared times the derivative of the second. Well, if I'm taking the derivative of the second, I got to do the same thing, right, with these ones here. So derivative of the second, okay, is now second x minus 3 times the derivative of the first plus first d second. Alrighty, so let's just tidy this up a little bit here, simplify it. Okay, x minus 3 squared times 2x plus x squared times 2 times x minus 3. Awesome. Right, so we want to factor this as much as possible right now. I think I can take out a 2x and x minus 3 from everything there, which leaves me with x minus 3 plus x. So I'm getting 2x, x minus 3 times 2x minus 3. And there is my nice simplified derivative. Awesome. Let's try another one. Right. So again, you want to think about this as I've got one, my first, and my second. Right, rather than expanding this all the way through there. So my y prime is my second, 2x squared plus 2x plus 4 times the derivative of the first plus the first d second. So that gets me to 4x plus 2. Awesome. Well, okay, let's factor out a 2. That first one multiplied by that 4, that gives me 8. X squared plus x plus 2 plus, well, I can factor out a 4 from the first bracket and a 2 from the second bracket there, so I can get an 8. And if I factor out that 4, I get x minus 2, 2x plus 1. Alrighty. So let's factor out that 8, and I'm going to expand those binomials in my second term there. Really, so I'm going to get 2x squared minus 3x minus 2. And then we can just simplify that bracket there. Okay, we get 3x squared minus 2x. Alright, and then factor out an x from that. And there you have our derivative. Awesome. Alright, we want to find the derivative for each when x is equal to 3. Right, so I want to find the derivative when x is 3. Again, there's my first, there's my second. But again, we also have in that second, I actually have a product happening. Right, so I have a first and a second when I'm finding the derivative of the second. I got to use the product rule within the product rule. Product rule inception. Alrighty, so my y prime. Second. D first. Plus first. Times the derivative of the second, which is a second, times the derivative of the first, plus the first times the derivative of the second. Awesome. I'm just going to tidy that up a little bit. Don't need to go too much into my factoring and tidying up because I know what value of x I want to sub in there. I just want to make this one a little nicer here. There we go. Alright, well, I don't need to go any further than that because I want to know when x is equal to 3. So at x is equal to 3, my y prime would now be, what do we got? 3 minus 3 squared, 0 squared, multiplied by 3 times 3 squared. Alright. Plus 3 squared, 27, times 2, 0. Alrighty, well, that's just going to end up being a whole lot of 0. Okay. So my derivative when x is equal to 3 of this function is 0. Right, so that means the slope of my tangent is 0, so I have a horizontal line at x equals 3 as my tangent. Let's do the same thing here. Right, so I've got 3 terms being multiplied together. Again, you can split this up in actually a couple different ways. So I'm going to go through and say, well, here's my first. It's just my first bracket there. And my second is my second set of there, right? Again, I still have a product rule inside of a product rule. You can get the same result if you look at it as there's my first and there's my second, right? Either one, I'm still going to get to the same answer in the end. So I'm going to do it with my first and second in my blue there, right? So my g prime of x, right? So second, so So that's my 2 brackets, 3x plus 1 times 2x minus 3 times the derivative of my first, which is just 2, plus my first 2x minus 1 d second. So the derivative of my second, gotta take the product rule again, right? So my second and my first of my second function there. So I'm going to have 2x minus 3 second d first plus my first d second. Awesome. Right? Again, you can go through and simplify this, right? But because I know the value of x that I want to find at, I'm just going to sub in x. Right? So I'm going to find my g prime of 3 and sub in 3. Alrighty. 3 times 3 plus 1, so I get 10. 2 times 3 minus 3, 6 times 2 plus 2 times 3 minus 1, 2 times 3 minus 3, and go. Alrighty, so now we can just evaluate this. So what do we get? Oops. No, there should be a 3. So I get 60 plus 5 times 29. Right, so 60 plus 145 and 205 is my answer. Right, so my slope of my function at x equals 3 is 205. It's a really steep slope. Right, and you would have found the same answer had you done it with your first being the yellow highlighted terms and your second being the orange highlighted term. You'd still end up at that same answer of 205. One more example here. Let's find the slope of the tangent to f of x equals 2x plus 4 times 3x cubed minus 3x squared plus x minus 2 at the point 1, negative 6. Again, I'm finding the slope of my tangent at a given point. All I care about from that given point is my 1. Right? Unless I was finding my equation of the line, I don't care about the y value. All right, awesome. So it means I need to find my slope, so I need to find the derivative. So I f prime of x. All right, I've got two things being multiplied together, so let's use my product rule. So second, 3x cubed minus 3x squared. Second times the derivative of the first, which is just 2, plus first times the derivative of the second. Awesome. Again, you can go through and simplify, but I know what value of x I want to put in, so just sub in 1. Right, so if I put in 1, oops, prime of 1, right, so I'm going to get 3 minus 3 plus 1 minus 2 times 2 plus 2 plus 4 times 9 minus 6 plus 1. Right, and then evaluate there. And what do you get? Minus 1 times 2. 2 plus 24, and we get 22. So there's the slope of my tangent at the point 1, -6. All right, awesome. So that's your product rule. Second d first plus first d second. All right, so some practice in your textbook. Page 145. That's a 5. Number 1, 4. Don't worry about F. 5 to 6. 7a. 10 and 12. Awesome. Have a great day.